Good evening, folks. Thank you all for showing up this evening. My name is Stuart Hood. I'm the senior preparator here at GulfQuest tonight. And tonight we have Jason Beaman. He is with the National Weather Service based out of Mobile. And thank you all for showing up for GulfChats. This is a monthly occurrence, so please keep an eye out for any of our upcoming events in the future. And without further ado, here's Mr. Beaman.
Well, it's a pleasure being with you all this evening. Talk a little bit about hurricanes. And first off, how many people are longtime coastal residents of the area? Okay? So a few, and then there's a lot that we can learn from our past experiences kind of as we look forward. And that's one of the only, we love to get out and do preparedness messaging. For those that don't know much about the National Weather Service, your local National Weather Service is based out of here in Mobile at the regional airport. If you've ever been by the regional airport, you see the big white ball on the tower. That's our Doppler radar. So that's the radar that's used in our local area to tell where it's raining, where the storms are, coming from the National Weather Service. And our office is right there. And we serve the local area. We have 20 counties in total in 3 states. We basically cover from Dauphin Island to Destin along the coast. So we're your local weather experts. We have a team of about 20 people, 15 meteorologists in total that are dedicated around the clock to watch the weather, especially in times of significant weather. And again, preparedness is something that's important to us. We don't want to turn a blind eye and like nothing to see here, because a lot of times we get complacent along the coast. We had Sally from a couple years ago, so maybe the complacency isn't there right now. But before Sally, it had been a while since we had a significant hurricane, and it caught a lot of people off guard. And so this is a time to learn. I really encourage interaction, questions at the end, or if you got something that I need to clarify during the middle, I'm informal, so please don't hesitate to speak up. But it's about learning. The first thing I want to tell you about before we go too much further is our website. Again, the National Weather Service is a federal government agency. Your taxpayer dollars, my taxpayer dollars, pay for the National Weather Service. We're your local resource, and we consider it a public service to serve you all. And so for everybody, weather.gov/MOB, it's kind of like weather.com without the commercials or the advertisements. That's what we always joke about. But seriously, we have a local page, and we try to make it really easy to find information. The biggest thing in a hurricane situation is there's so much information. What do you listen to, right? Well, we try to make it very simple. If we have a tropical event, we always have it at the top of our page, an easy link that you can reference. And what it does is it takes you to kind of a one-stop shop for all of your hurricane needs, so to speak. If you're interested, hey, is there any storms out there potentially? Are they watching any areas of development? You can see that in the tropical weather outlook. If there's any active storms, what's the forecast? What's the storms looking like? All right there on that same page. What about any potential heavy rainfall, surge threats? Anybody live in a surge zone or an evacuation zone here? Okay, that's good. So surge is a big thing for our part of the coast. And so all that information, again, is in one area. And what we try to really do is there's multiple hazards in a hurricane. You'll hear me say many times tonight, you can't focus on the category of the hurricane to figure out what the total threat's going to be. It can kind of maybe lull you into a sense of complacency you don't want to have. So we have individual threats for wind, storm surge, flooding, rain, and tornadoes. And we put a simple color-coded system of what the threat level is for your local area. So you can click on your local area where you live, and you'll get a lot of information about what the potential threats are for you. It really helps you to kind of quantify what the potential is, because you're going to hear so many numbers out there during a hurricane. Trust me, social media especially makes it even more challenging. So we're here to try to help cut through the noise and provide you easy to understand, actionable information to be prepared for a storm. So again, that's weather.gov/MOB. So as we talk about hurricanes, obviously we're now, basically today is September 8th. The average peak of the hurricane season, if you look historically, is in 2 days, September 10th. This chart here kind of charts out from May to December, and the amount of hurricane activity you can see there in September is the climatological peak. But we have a long way to go still. And history shows us on the Gulf Coast, the northern Gulf Coast, we got to ride through October until we could basically say, all is well. I used to be able to say in these talks, give us through mid-October and then the cold fronts start coming down and we're pretty good. Well, Hurricane Zeta from 2 years ago happened at the end of October and okay, well maybe we got to go through all of October. But typically once we get into November, the activity starts to wind down, and especially here, we're starting to get those nice cold fronts, those nice north winds that kind of keep the hurricanes away. That's my favorite time of year right there. So if you look by month, again, these are kind of shows you the average areas of development where you're most likely to see development, and it's no surprise that September, here we are in the peak of the hurricane season. What's been interesting so far this hurricane season is we've had rather few storms overall. We've got a couple hurricanes out there right now, way off in the North Atlantic. It's not going to harm anybody. That's good. That's typical for this time of year, but we really haven't seen a lot of activity overall in August getting into September. We hope that remains the case, but history typically shows us that there's going to be more storms to form out there than we currently have. So, and it really doesn't matter how many, it's where they form and where they make landfall, if they make landfall. If you look historically across our part of the Gulf Coast, we average a hurricane direct strike every 9 to 10 years. Now that's an average, right? There's been periods of time where we've had a lot of storms in a very short period of time, and then we've had very long breaks. You think about after Hurricane Katrina that impacted us in 2005. We went a long time, over 10 years, until we had another significant hurricane impact. Well, then you had the seasons of 2020 and 2021 with a lot of activity in the northern Gulf. So again, the averages are kind of the average of the extremes, right? So it doesn't mean that because we had Sally in 2020 that we're good for another 9 to 10 years. That's just on average what we typically get. But again, it does not take a major hurricane to produce major impacts, and I really want that to be a theme as we go through this. And I've got lots of examples from our past hurricanes to show you why it doesn't take, when I say major hurricane, we have a Saffir-Simpson scale of 1 to 5. A major hurricane is considered a category 3, 4, or 5 based on the wind speed and the wind speed alone. It can't tell you the whole story about a hurricane's impact to the area. There's many examples, and all it really takes is one storm to make it a bad year for us. A couple of the more notable examples is Hurricane Andrew. We all remember hearing about Hurricane Andrew, even if we didn't go through it. That was one of the only few hurricanes that actually formed that year, and it was the first hurricane didn't form until late August, but it happened to be a category 5 that hit South Florida and was one of the costliest storms on record. The rest of the hurricane season that year was fairly uneventful. So again, that one. Anybody in here go through Hurricane Danny in 1997? And so Danny is known for its rain. Lots and lots of rain, historic rain. I'm not talking about 5, 10, 15 inches. I'm talking about 20, 30, 35, close to 40 inches of rain in spots with Hurricane Danny. And lots of roof damage because it was so slow. So again, it was just a category 1. I say just a category 1. It produced historic flooding and prolonged wind. Sometimes it's not how strong the wind is blowing, it's how long that wind is blowing to produce impacts. Sally was another example of that. So take a few of our seasons from the past. 1997, that was the year of Hurricane Danny across the northern Gulf. And you can see here, that's the only storm in the Gulf of Mexico the entire year. We had very few storms all through. There was only 8 named storms the entire season. But for us, in Mobile and Baldwin counties, it was a bad year. It just takes one. Again, here's a little more about Danny. This is just a satellite loop, or a radar loop, pardon me, for just a brief period of time. It basically stalled over Mobile Bay for the better part of a day, day and a half. It decided to vacation here on the northern Gulf Coast for a while, and it dumped copious amounts of rain. You can see the Dauphin Island Sea Lab measured 36.71 inches. That's an actual measurement. There was radar estimates in Mobile Bay of over 40 inches. You can see some of the impacts. We had washouts, significant flooding along our area rivers, lots and lots of damage across the area just from the rain alone. Something that the category, it's the lowest category, it's only a category 1. We look at a 2005 hurricane season, what a mess that was. Lots of major hurricanes, lots of significant hurricanes across the Gulf especially. This was the year of Katrina. It was the year of Hurricane Dennis that impacted mostly the Florida Panhandle, but certainly produced a scare locally, especially in the wake of Hurricane Ivan the previous year in 2004. So that's a season where, yeah, we had a lot of storms, and a lot of them found its way to us. So high, active season, high local impact. Well, compare that to a season like 2010. Look at all the storms out there. We're talking about 19 storms overall, well above normal, but except for a very weak system in the Gulf, we were left alone. So we don't remember the 2010 hurricane season, but the perspective of the Caribbean was a whole lot different that season. So it's all about local perspective. So even when you hear those outlooks of, hey, we could have a lot of storms this season, that's not talking about specifically here. There's no way we can tell you where the storms are going to go months in advance. Boy, if we could, we would be living right. But obviously that's not the case. And something that I think history has shown us that is even more important is that we don't always get a long time to prepare. Sometimes these storms come up quick. Sometimes they strengthen rapidly right before landfall. And as good as we're getting on the track forecast of the hurricane, we still have a ways to go in our skill in predicting the intensity of the hurricane. So Hurricane Opal is one of the more notable ones here locally. It went from a personal story. I was helping my dad board up. I was living in Foley, Alabama at the time. We boarded up the night before landfall as a Category 1 hurricane. We woke up 6 a.m. the next morning, turned on the TV, and it was almost a Category 5 hurricane. You talk about startling, right? And it made landfall as a major hurricane. It actually shifted just east of the Alabama coast and made landfall in the Florida Panhandle, but it caught a lot of people off guard. Lots of last-second evacuations. People almost got stuck on roadways as the hurricane was making landfall. So again, we have to be, when you hear the intensity forecast, give yourself a safety margin. We always tell you to at least prepare for a category higher on the wind speeds. That's just a natural safety margin that we've got to factor in because we do get storms like this. And we get storms like Hurricane Michael that didn't impact us locally here, but over in Panama City, it was the worst storm that they've seen in modern times. Again, another rapidly intensifying hurricane from a Category 1 to a Category 5 in 48 hours. That's what happens here a lot, is rapid intensification. We even saw it in Sally. Sally was, the day before landfall, Sally was barely maintaining hurricane strength all day. We were feeling pretty good about the intensity forecast. Then about 9 o'clock that night, I'll never forget it, sitting there in our operations area, operations floor, and we saw the hurricane hunters go in, that pressure started dropping, and the wind started increasing quickly. In a matter of 4 hours, it was almost a Category 3 hurricane, moving at a snail's pace. I think a snail was moving faster than Sally at times. So again, we have to give ourselves a safety margin when we're talking about these storms. This is one of the most interesting things that I show that's really striking. If we take a look at the nation's most powerful hurricanes 5 days before landfall, where were they and how strong were they? Well, the Labor Day storm of 1935, Camille in 69, and Hurricane Michael didn't exist 5 days before landfall. And they were all Category 5s at landfall. Andrew was barely a tropical storm way out east of the islands and almost got completely ripped apart. So 5 days before landfall, none of them were a hurricane. So let's look at 3 days before landfall. The historic Labor Day 1935 hurricane was a minimal tropical storm. Camille was a mid-range tropical storm. Same with Andrew. Same with Michael. We see a theme here, unfortunately. So all five of these storms were tropical storms that rapidly strengthened just 3 days before landfall. So just think about it, something to take home. Would you be prepared if you only had a couple of days to enact your hurricane plan? And before that, do you have a hurricane plan? If we have a hurricane threatening our area, do you have a plan of what you will do for you and your family, given your specific situation of where you live, and whether wind or flooding or storm surge is what you're most vulnerable to? So think about that. If you only had a few days, because it's not just surviving the storm, it's living in the aftermath of the storm with the extended power outages and the things that really make life not so much fun after a hurricane moves through. So just something to be thinking about. And history has shown us kind of that perfect example too many times to count. Now, a little bit about kind of being prepared, getting ahead of the information. The National Hurricane Center, throughout the entire season, you see this a lot on local television, shares this information. The National Hurricane Center is a part of the National Weather Service. And they produce a 5-day tropical weather outlook, 4 times a day. So constantly update it. You can get it on our website that I just showed you, or you can go to hurricanes.gov, and it will show you the 5-day tropical outlook. That gives you an idea of the areas of concern that the Hurricane Center has of a storm that might develop. That's kind of a good thing to kind of keep an eye on through the season, just to kind of be in tune. And then, of course, as we get a storm, we're all familiar with the forecast cone. Everybody seen this before? Very familiar with this? How many of us, and be honest, nobody's going to get judged here, how many people automatically focus on the center of that line and nothing else? It's human nature. It's kind of human nature to focus in the middle. Well, I want to give you some reasons why, just to be cognizant of what this cone really means. As good as we are in hurricane forecasting, obviously we can't pinpoint the exact center of the hurricane several days out. So we have a forecast cone that basically is an average of our historical track errors. That kind of shows you, obviously, in the first few days of the storm, the cone's pretty small, our errors are pretty small, and that cone gets bigger and fans out as you get further in time, as our uncertainty increases and our historical errors increase. What this cone is telling you is that 2/3 of the time, the center of the storm will remain in that cone. What's that mean the other third of the time? It's not going to be in the cone. So it's not always going to be in the cone. There's some storms that are very challenging. And also, it's not a cone of impact, right? It's only talking about the center of the storm. Hurricanes' impacts intertropical storms' impacts can be far-reaching, well away from the center. Even in this example, all these areas of blue and red are tropical storm and hurricane warnings, and they're well outside the cone. So again, it's a good tool, it's a good piece of information, but it's not everything to focus on. I'm going to use Hurricane Sally as the perfect point in this. I know during doing our storm surge surveys along the coast after Sally, there were many people, and the most interesting thing about going out and doing surveys afterwards is obviously we document things for the historical record, how high the water got, so forth. But what interests me the most is talking to people, hearing their stories, hearing how they were using and receiving information, and what can we do better for the next time. That's what it's all about. It's because it's about helping people. And I had so many. I wish I would have taken notes and actually, you got a percentage, said we thought this was going to New Orleans. Time and time again, that's what we heard. Well, this was the forecast track from Sunday, September 13th. Sally made landfall the early morning hours of Wednesday, September 16th. So 3 days before landfall, yes, the center of the cone was towards New Orleans, and that's, I think, what a lot of people focused on. And we were just outside the cone by a smidge. And so a lot of people let their guard down. Sunday, and I base this just off personal anecdotes of family and friends. Sunday was kind of a day the guard went down. But at the same time, we had a tropical storm warning, we had a hurricane watch, we had storm surge watches and warning watches for the coast, and we were also talking about potentially historic rainfall of 20 to 30 inches. But yet, a lot of people tended to potentially let their guard down. And we obviously know what happened with Sally. It made landfall in Gulf Shores, Alabama. So Sally is a very real example that the cone only tells a part of the story and cannot tell you everything going into a hurricane situation. Hurricane Katrina is another one. It made landfall on the Mississippi-Louisiana line and produced hurricane force winds and a near record storm surge in Mobile Bay. The July 1916 hurricane is the largest storm surge on record here in the north in Mobile Bay. Katrina got very, very close. A historic storm surge, and the storm center was, about 100 miles away, 100 miles to the west of Mobile. It's not always where the center is. Katrina was an extremely large storm. So obviously with a large storm, with a large amount of area of wind, it could push a lot more water to the coast. So just some considerations for you thinking when you look at future forecast. I use Hurricane Irma here. Hurricane Irma, you can see here, this was the forecast cone for Hurricane Irma. What you see here in the red and the orange is some of the highest storm surge associated with Irma. That was outside the cone. And this is an image here to the right of how much rainfall. A large part of the state of Florida received 15, 20 plus inches of rain that was nowhere near the center of circulation. So again, don't focus just on that center of the storm. History tells us that we can't afford to do that. Now, how many people have seen or heard about spaghetti plots, the spaghetti models? All right. So this is my soapbox moment. Allow me to get on my soapbox for just a moment. This is something that I think can cause a lot of confusion, and it's not always articulated well, of the caution that you have to use when looking at these spaghetti plots. The spaghetti plots, depending on the source and where you see them, can be very different, and they usually contain three key elements. They contain some good things, reliable computer models that meteorologists use to help us produce our forecast. There's a lot of bad sometimes, a lot of old computer models that kind of still are projected or still shown that we don't really pay attention to. And then the ugly, some of them, do you know some of those lines that you see are not even computer models? We have a thing called a climatology line that can just show you, based on average historical information, where it typically goes, but nothing about the current atmosphere. There's another one that just says, hey, if it keeps moving at this current direction and speed, it'll go here. Not very helpful. But unfortunately, these types of things get posted on the internet today. As great of a tool as social media can be, it can produce a lot of misinformation and get people alarmed unnecessarily, because sometimes we could be okay, but one of those ugly lines could be headed our way and kind of get people stirred up when they don't need to be. The last thing we need to be doing is worrying when we don't have to be. And so it's a meteorologist's job to filter through all this information. Let us do that legwork. Let us do that work, what we're trained to do, that we've gone to college for many years, spent our whole careers training on, and not so much rely on these. Here's an example from Hurricane Ike back in 2008. The white line you see here is the actual track of the hurricane. Ike made landfall near Galveston. This is just a series, an animation of all the computer models, the spaghetti plots. You see how there was wild swings, right? At one point, well, they're all going to Florida. Well, no, not so much. Okay, well, what about South Texas? Nope, just kidding. And then up to Houston. So again, just one example, used with an abundance of caution. Again, our worry is sometimes that there's so much information out there, it's just really hard for people to kind of figure out what to look at, what to trust. And that's something that we take seriously. So when it comes to spaghetti plots, just say no. Just say no. There's lots of better tools and information out there for you to look at during a storm. And one thing that a lot of people, again, we focus on the category of the storm a lot. I mentioned that several times, I'm sure already. But it's really the water that is killing people in hurricanes, especially when it comes to storm surge and freshwater flooding, not the wind. 76% of all fatalities in tropical systems is a result of the water, of surge or freshwater flooding. Wind is less than 10% on average. So again, wind is very serious. Wind can damage our home. Wind can blow down a tree and put it through our home. Don't mistake me. I'm not saying wind is not important. It's something that we have to be prepared for. But historically, it's not what has taken people's lives. And that's our first and foremost concern, is protecting life and property. So storm surge, we all know storm surge. It's the abnormal rise of water generated by a storm. So think of all the wind in a hurricane, and all that wind kind of piling water towards the coast as it moves towards the coast. And it typically comes in as a surge. It's not a gentle rise of water. It's not there 1 minute, the next minute it's there. And it can be very violent, and it can produce a lot of damage. It can scour away complete towns, coastal towns. This was Mexico Beach in Hurricane Michael, the Category 5 hurricane back in 2018 that hit near Panama City. That is complete devastation from storm surge. That's not wind. That is the power of water. We look back at history. I mentioned the July 5th, 1916 hurricane that made landfall in Pascagoula. It is the record storm surge for Mobile Bay. To this date, it is the highest storm surge ever officially recorded at 11.6 feet. But it's not the highest storm surge Mobile Bay can receive. If you take a hurricane like Katrina and shift it to near the Mississippi state line, Mississippi-Alabama line where the 1916 hurricane went, you could have water 15 to 20 feet in Mobile Bay. So again, just because that's all that's happened doesn't mean that's all the potential that is there. But again, it shows our long history with hurricanes. There's many other notable hurricanes I could share, but the 1916 one still stands out in the historical record. It produced over 100-mile-an-hour winds over a large part of the area and was a very devastating storm for the time. And the big thing about surge is, again, it's not just the wind. It's just not that category number. Again, the category refers to the wind speed. There's many other things that kind of factor into the storm surge equation, the storm surge formula. The big one is size. How big is it? Just think about it. The bigger it is, the bigger arm reach it has to push water to the coast. If you have a tiny storm, just a little bit of an influence on the water. Big storm, big push. And so that's one of the big ones. We used to tie storm surge to the storm category. So this is back the old Saffir-Simpson scale that equated a Category 1 with a less than 6 foot surge going up to Category 5, a catastrophic surge. That's the original Saffir-Simpson scale. But look at these notable storms that defy that. Katrina's at the top of the scale. Yes, Katrina was a Category 5 in the middle of the Gulf, but it made landfall as a Category 3 hurricane. Ike, that hit Houston, Galveston, was a Category 2 hurricane, but an exceptionally large Category 2 hurricane, produced a 20-foot storm surge on the north side of Galveston, the Bolivar Peninsula. And it was only a Category 2. You look at a storm like Charlie that hit just south of Tampa back in 2004. It was a Category 4, but it was small. So it didn't have that influence over the water to result in as high of water levels as these other weaker storms that were bigger. So that's why we don't reference surge with the storm category anymore. That's why it's the Saffir-Simpson hurricane wind scale nowadays. Ivan is a great example. Anybody here through Ivan? Okay, Ivan is an example of why track matters and small adjustments mean big things to how much storm surge we can get. This is the forecast 12 hours before landfall of Hurricane Ivan. Hurricane Ivan was a Category 3 hurricane at landfall. 12 hours before landfall, the skinny black line was right up Mobile County, a worst case scenario for Mobile Bay. But you see the forecast cone encompassed the entire area. Now, if we were to look at a simulation of where the highest water would have been based on that skinny black line, the bright colors here is the higher levels of surge. We're talking about, we're getting close to 14, 15 feet at the northern end of Mobile Bay. Look at Pensacola over here. 2 to 4 feet of surge if the skinny black line worked out. Well, it shifted just a little bit, 30 miles or so to the east, may landfall in Gulf Shores in the last few hours before landfall, and it changed everything as far as the storm surge goes. All the water went into Baldwin County and into Pensacola. We had north winds in Mobile Bay. So the surge did not come into Mobile Bay, it went into areas just to the east. Now, when we're preparing for a storm, there's no way I can say, hey, Mobile Bay is going to get all of the surge, Pensacola, you're looking good. No, I got to say, hey, Mobile and Pensacola, you've got the same threat right now of a very significant storm surge. Because think about it, we got to make this, if you live along the coast, you got to make decisions well before the hurricane makes landfall. These are things that are happening less than 12 hours before landfall. That's the nature of hurricanes. So, and here's an interesting example from Hurricane Michael. This is Michael's actual track. This was Mexico Beach, where we got about a 10 to 13 foot storm surge. If we would have shifted this line 30 to 50 miles, look what it does to the Big Bend of Florida. So, disaster here becomes disaster here. I wish we were that good 24 to 48 hours out when we have to get people off the coast, but we're not that good. We have uncertainty, and that's why we have to sometimes evacuate. Local decision makers, emergency management officials have to factor all these things in and where to call evacuations ahead of time. And there's going to be those that unfortunately get it and get it really bad, and those that are spared the worst. That's just what small track differences can do. So what we've done at the National Weather Service is we've tried to produce a map that shows you, based on what we think is what we call the myriad of solutions, the possibilities with this given storm, here's how high the water could get. We call it a potential storm surge flooding map. It's produced with every hurricane. And it depicts all that uncertainty. So when in Ivan, if we had a map like this during Ivan, which I wish we did, we would have had the same threat level of water rise in Mobile Bay as we did Pensacola and Escambia Bay to show that there was an equal threat at the time. So these are very valuable tools, especially for our emergency managers, to help make solid evacuation decisions, factoring in the inherent uncertainty with a hurricane. Here's kind of a zoomed in local case I got here from the Florida Panhandle. It's color coded to show how high the water could get above normally dry ground. The reds are up to 9 feet or above of water. That's if I was on this part of Okaloosa Island and I was in that red area, that means the water could be 9 feet from where I'm standing. So we try to show areas that could get significantly flooded. It's been a game changer for us in being able to message storm surge, because back in 2004, we didn't have these tools, we didn't have these capabilities. It's very hard to describe storm surge just verbally or in text. Pictures speak 1,000 words. So that's why we have storm surge watches and warnings that we issue nowadays to alert people in vulnerable areas. And a large portion here of downtown Mobile is very vulnerable to storm surge. We saw it in Hurricane Katrina. Storm surge can impact a large area of downtown Mobile in areas down along the coast of Mobile Bay for the Dog River, down south to Dauphin Island, Bayou La Battery, Codin, all very vulnerable to storm surge across our area. So we always tell people, know your evacuation zone. Now is the time, and if you don't know it, emergency management, how many people have heard of local emergency management agencies? Are you familiar with local emergency management? They're a fantastic resource that too few people know about. We partner with them. They are county officials whose sole mission is to prepare their counties ahead of the storm, to help make the evacuation decisions, to help schools give an idea of when they need to close down. All those different things that factor in. We work directly with emergency management. We provide them the weather information, the best we have, and they take that information and make the best decisions for their counties when it comes to resources, evacuations, likewise. They all have a website. If you live in, we have Mobile County residents in here? Any Baldwin County residents? Anybody anywhere else? Okay, so if you just search your Baldwin County Emergency Management or Mobile County Emergency Management, it will take you right to their page. You can get a lot of great information from them, especially if you live close to the coast. They can let you know what evacuation zone, if you are in one. So again, it helps spread that word. Emergency management, there's no harder workers than in emergency management. And your local emergency management here in Mobile County is over by the Mobile Fairgrounds, next to the 911 center. So right here in the heart of Mobile County. Now I talked about freshwater flooding. If we look over the past 5 years, we're doing a lot better when it comes to storm surge. We've had a lot of big hurricanes in the past 5 years. We've really started to reduce the number of fatalities in storm surge. I think that's a great success for our country. But we're still losing a lot of people due to freshwater flooding. Because people underestimate the power of water. They see a water-covered road. A lot of times they drive through. But we don't know if there's a road. What's the condition of the road? Is the road been washed out? How fast is that water moving across the road? A lot of things can get you in trouble really, really fast.
I have a question.
Yes, sir.
In the previous slide, you were talking about the evacuation zones.
Yes, sir.
Is that something that's fixed, or is it changed for every storm?
So each county has a set zones. So there could be like zone 1, zone 2, zone 3. Depending on the storm, will help them determine which zones to call for an evacuation. So, in a lower end storm where it's mainly only the kind of the lower, most vulnerable areas, you may only have the zone 1, for example, evacuated. If it's a bigger storm, they may have to go to a couple of other zones. So it's really storm dependent, but based on where you live, there are dedicated zones, a zone for that. And it's really important to understand what zone you fall into. So when you hear that information, hey, Mobile County's called for an evacuation for these zones, does that apply to me? Or where am I in relation to the water? What's my, am I in a direct threat of storm surge? County emergency management can really help you figure out what your local threat is. I really encourage everybody to do that. So there's some examples. I'm not even just using local history here. I helped the National Weather Service do an assessment of Hurricane Florence that impacted North and South Carolina back in 2018. And it was a very striking case. Florence was a very large Category 4 hurricane coming towards the coast. And then it weakened to a Category 1. And a lot of people stopped paying attention. But what wasn't changing, even though the category what wasn't changing was that 20 to 30 plus inches of rain was coming because it was moving excruciatingly slow. That wasn't going to change. So a lot of people let their guard down on the flooding risk when they heard about the change. So great news for the wind aspect of it. The wind's not going to be as bad. That's a good thing. But that rain's still coming, and it doesn't matter the number of the category. 17 of the 22 direct fatalities in Florence were the direct result of flooding and produced $24 billion in damage from a Category 1 hurricane. And the forecast was remarkably accurate for the rainfall. This was the forecast. The color scales are representative here. They're the same color scale for each side. The bright purple here is 25 plus inches of rain. And this was a forecast produced a 5-day total forecast, several days out. That's remarkable forecasting skill as a meteorologist. It doesn't get much better than that when you're trying to forecast something as challenging as a hurricane, a slow-moving hurricane. Hurricane George is a great local example. Again, not a major hurricane, a Category 2 that came up and produced extensive rainfall. Some areas of the Florida Panhandle received over 30 inches, 38.46 inches of rain in Munson, Florida, the northern inland Florida Panhandle. The hurricane made landfall in Mississippi. So again, it's not the center that matters. Ida, Ida was the big hurricane that hit southeast Louisiana last year. We had 3 flood fatalities in George County, Mississippi from a road washout, a major road washout, because a band set up 7 to 11 inches of rain in a very short time, and it completely overwhelmed the infrastructure. And we sadly lost 3 people. We had multiple injuries from a storm that made landfall quite a ways away. And I could have shown Sally again here too. Sally was not a major hurricane. We got 30 inches of rain along the coast. Orange Beach, Alabama received 29.99. I'm pretty sure they got 30. The wind just blew some of it out of the gauge. Again, a very, very major storm. Then we talk about wind. So this is the Saffir-Simpson scale for wind. Again, 1 through 5. But it's not just, again, even with wind, the wind speed is only part of it. How big of a hurricane do you have? How big of an area does it impact? The red area here, this is Hurricane Katrina. The red area is the size of the hurricane force wind field. So we're talking about winds basically 75 miles an hour and higher, right? Very, very large with Katrina. A stronger hurricane, Hurricane Charlie, as a Category 4, look how tiny the hurricane wind field is. So yes, so that really is part of the equation too, of how many people are impacted. But it's also about how fast it's moving. Danny, as you mentioned, a lot of wind damage in Danny. Sally was the exact same way. Sally was the worst of 2 scenarios. It rapidly intensified as a Category 2, and it was moving at less than 2 miles per hour. So some people were in the eye wall of the hurricane where the most intense winds are for a very, very long time, an extraordinary amount of time. Dauphin Island was on the west side of the hurricane, which is typically the weaker side. They still experienced 4 consecutive hours of sustained hurricane force winds. That's pretty remarkable. Foley had 20 hours of tropical storm force winds. Then, of course, they had a period of hurricane force winds in there, too. And Pensacola Naval Air Station measured 6 hours of nearly continuous hurricane force wind gusts. That does a lot of damage, and we saw that along the coast. It brought down a lot of trees, and, of course, a lot of those trees fell on homes. We had a lot of roof damage, a lot of significant wind damage because of the duration. If Sally would have been the same intensity and moving at a steady pace, the amount of wind damage would have been much, much less than it was. So it was about the time. It just wouldn't stop. It wouldn't get out of here. Peak wind gust. We had wind gusts of Category 3 intensity. So Perdido Pass had a peak wind gust of 118 miles an hour that was measured by a meteorological research equipment. We had a ship that was anchored in Ingram Bayou that measured 121 mile per hour gust. Its mast was up a little high, so that could have been a little high compared to what was right at the ground. But once you get over 100 miles an hour, you're talking about it for several hours, you're going to get extensive damage. So again, very large swath of wind that lasted a very long time. And Zeta was Sally's polar opposite. So Sally, the slow-moving, wouldn't get out of here hurricane. Zeta couldn't get out of here quick enough, but boy, it brought a punch to it, especially into inland parts of the area that we serve over inland southeast Mississippi and the southwest Alabama. It made landfall near New Orleans as a Category 3 hurricane, and it was moving at near record speed, almost 30 miles per hour at times. So what does that mean? You have a rapidly intensifying hurricane that is rapidly moving inland, it doesn't have time to wind down. So those winds carry way far inland. Do you know that Zeta brought the highest recorded hurricane gust to the Mobile Regional Airport since our modern equipment got put in several decades ago? 91 mile per hour wind gust. What was so fascinating about Zeta was our sustained wind speeds were generally in the 40 to 50 mile per hour range. The gusts were nearly double the sustained winds. So it's not just the sustained winds, the gusts have a big factor too. And in inland parts of the area, just inland, Citronelle up into Washington County, they had 100 mile per hour wind gust easily with Hurricane Zeta because of how fast it was moving. And then something that I always like to share in our outreach, rip currents are our #1 killer along the coast. If you go back to 1996, from Dauphin Island to Destin, Florida, we've had 133 fatalities from rip currents. You add up all of our other fatalities in that time, you don't even get close to what rip currents.
What is a rip current?
So a rip current is a fast channel. So basically it's in our Gulf beaches, over the Gulf waters at our beaches, and it's fast channels of water that quickly pull away from the coast. So what happens is somebody gets out in the water, and these fast currents are basically pulling people out deeper into the water to where they get overcome by the water, if they're not good swimmers especially, but even expert swimmers can be overwhelmed in strong rip currents. But they're under the water. It's hard to see them. And unless you really know what you're looking at, you really can't see them. And people get in trouble very fast. We average 5 fatalities a year from Dauphin Island to Destin. That's a remarkably sad statistic because unfortunately what's happening a lot of is that these are a lot of tourists that come down. And why do I share this with you tonight? We all have family and friends that I'm sure visit our wonderful beaches. And we don't want to scare anybody away from the beaches, but kind of our motto is, it's always a great day to go to the beach, just some days you don't want to get in the water. And you especially don't want to get in the water after during or after a major, or any sort of tropical system. A lot of times what happens, we get a lot of fatalities. Say the storm moves in and out, even say it was a tropical storm. Wasn't notably impactful, brought some wind, brought some rain, but it stirred up that water. There's a lot of wave energy that's happening even in minimal tropical storms. Storm goes away, the skies are blue and sunny the next day. Everybody's ready to get back in the water, but that water is not calmed down. And people get in trouble because of that. And so it's been our mission to try to get the word out each and every way we can about rip currents. In fact, if you go to our website year-round, one of the graphics you will see on our front page is a 4-day rip current outlook to try to get the word out of when there's a more significant threat. We do this obviously for locals, but we especially try to do it for those that are planning to come down to the coast too, right? Those that, hey, hopefully they'll see that high risk, because this is actually the one I pulled from today. So we're saying as of today, hey, over this weekend, we're going to get an increasing risk of rip currents. So those people that are coming down to the beach, try to get in one last late summer beach day, may not be the time to get in the water. So again, our website, weather.gov/MOB, a great one-stop shop resource for all your weather needs. We also encourage everybody to have multiple ways to receive warning information too, before and during the storm. How many people have a weather radio? Okay. How many people have it turned on? That gets everybody. Our cell phones have been a game changer, right? Our cell phones are a game changer. We can get tornado warnings on any of our new cell phones. You don't have to do anything. You can get a tornado warning. It's an absolute game changer. But as with any technology sometimes has hiccups, whether it be the phone, whether it be the cell tower, something. So we always encourage people to have more than one way to receive warning information. We also post a lot of information on our social media pages. We're active on Facebook and Twitter at NWS Mobile. Please follow us. We share preparedness tips during the quiet time, and when something's coming our way, we're trying to give you the best information possible. We're not here to hype anything. We're not here to scare anybody. We're here to inform because we're part of the local community. Our family and friends live here too. If I say something on there, it's the same thing I'm telling my family as well and my neighbors. So again, we're invested in this community. We're here to help. We also have a toll-free number here. We're a public agency. We're a public service agency. If you ever have any questions, any concerns, we got a storm coming our way, you're hearing things one way or the other, you're trying to figure things out, we're only a phone call away. But if you prefer to message us on social media, we're there too to try to help you. But the quickest way we can get back to you is if you call us on the phone. So again, I'll leave that up here as at the end of the presentation. I really appreciate your time tonight. I hope you learned something, kind of how our history can help prepare us better for upcoming storms, because it's not a matter of if another storm's going to come our way, it's just a matter of when it's going to happen. So thank you for your time, and I'm happy to answer any questions you all have. Yes, ma'am.
Are the powers that be looking at changing the categorization of storms to include the flood somehow, or have two numbers instead of just one number?
There's a lot of research actually going on in that from the Hurricane Center and the National Weather Service side. What we're finding is it's really hard to quantify something with one number. And so, but what we're doing is we're doing a lot. See, we're meteorologists. We know a lot about the atmosphere. We're not social scientists. So we're working with social scientists that are experts in asking these questions and how we can most effectively communicate these threats. So there is a lot of research work going on looking into that very problem.
To what extent do you think the climate change that's occurring is going to affect the future of hurricanes and tornadoes?
It's still kind of a mixed bag when it comes to a warming climate. When it comes to hurricanes, it's been actually a little bit more inconclusive over time. If you look at the historical record of hurricanes, the amount of storms we're getting in the Atlantic, we haven't seen noticeable changes. What we've seen a lot of is in a warming climate, we get a weaker jet stream. What I mean by jet stream is those fast winds aloft that steer storms along across the United States. So when you have weaker steering currents, you get more storms that don't move as fast and things of that nature. So what we're seeing is the amount of flood events that are happening, the amount of storms that are very slow moving, extreme heavy rainfall events. Those are increasing in frequency because in a warmer climate, so is the overall moisture content of the atmosphere. Warmer air can hold more moisture and more water. And so those are things that we're noticeably seeing already. And we've also seen some sea level rise. If you look at historical tide gauge data from like Dauphin Island and area, we are seeing water level rises. NOAA has a lot of great information online about how much water levels have risen over the past several decades and kind of some projections. So there are noticeable impacts. How it affects storm intensity with hurricanes, I think is still kind of an area of research that we're looking at.
One more. Anybody else?
I'll ask you that. I'll come back to you.
Has any speculation of why it's been so quiet this year?
There's actually been a lot of talk. I mean, we've had a lot of internal chatter. The first thing, we don't use that Q word in the National Weather Service because we're afraid of jinxing ourselves. It seems like every time we say, oh, it's been, we end up paying the price. But no, you're right. It's been obviously we call for a lot of activity this year, and it hasn't happened up to this point. From some of the things that we're looking at, there's been a lot more dry air overall in the Atlantic than what was modeled well ahead of time. And that's one of those things that our computer models that's one of the limitations of seasonal forecasts. Sometimes we get more dry air, we get more kind of stable air over the Atlantic. Exactly why that's happening, I don't think we've quite answered yet. But there's been a copious amounts of dry air, which dry air is not a hurricane's friend because thunderstorms can't grow as easily and things of that nature. Plus the wind shear, the winds in the atmosphere, the upper parts of the atmosphere, have been a little stronger than what was earlier indicated as well. As those thunderstorms try to grow, if you got a lot of winds in the upper levels of the atmosphere, it kind of cuts them off and doesn't allow them to keep growing and developing. And that's how a hurricane's a big heat engine that has to keep having constant thunderstorm activity. So that combination of dry air and a little bit higher wind shear so far has helped keep things in check, but it's only September 8th. So, we'll have to kind of see how things evolve. There's been some good signs though. But we get one storm that gets going in the Gulf of Mexico with the right conditions. The Gulf is very above normal water temperature wise. Now, it's not just about water temperatures. The Gulf's warm every year. The Gulf's very warm this year. And what that would do is, if we get the right conditions, it could allow a storm to quickly intensify. So that's my big concern. That's why I'm always guarded when, it's been good so far, but we've historically had some of our bigger storms in late September, early October in our part of the world. So fingers crossed, and I hope we keep the momentum going.
Why is Category 5 the highest category? Could it go even higher than that?
So we've had some, so Category 5 starts at 156 miles an hour, and there's no upper limit to the scale. There's been a few storms that we've measured winds up to 180, 190 miles an hour. There was one storm that in the Pacific that got up to about 200 miles per hour very briefly. There's been some talk about a Category 6 and things of that nature. When it comes down to it, once you get to a wind speed of a Category 5, it really becomes indiscernible. The type of, the level of damage and destruction is going to be about equal. And for most of our hurricanes that we see, don't really exceed the limits of to the point to where it's been felt that's justified to go to a Category 6 yet. There's certainly been storms that, again, have been 180, 200 miles an hour on very rare occasions. But most Category 5s in the Atlantic are typically 160, 165, something of that nature. But at that point, you're talking about catastrophic damage. So it's kind of at a point, just like with a tornado. Once you get to an EF5, theoretically you can go even higher than that, but it's complete devastation. So that's kind of why there hasn't been a big push. There's been some talk about it.
Has the technology for more accurate forecasting changed much over the past 5 years, and is there anything on the horizon that's going to even improve it more?
Yeah, our computer models continue to get better and better. They're far from perfect, but the advances we've seen over the years has been remarkable. There's still a lot of work to do. And that's really with all of our technology that goes into the computer models. Our satellite data has changed dramatically over time. When I first came to the Weather Service 20 years ago, we got updated satellite images typically every 30, 45 minutes, very coarse resolution. And sometimes we could get every 15 minutes, and we were really excited. Nowadays, if we want to, with our new satellites that have been launched over the past few years, we can look at a hurricane and get an updated image every 30 seconds. And it's basically like going from black and white television to high definition color, the level of resolution and detail that we can see from those satellites. The better the satellites get, that goes into the model data. Plus our computing resources are getting better and better. And so our models are gaining skill, especially when it comes to the track of hurricanes. Where they're still struggling is in the intensity. There's a lot of work being put into getting models to be able to better capture all the processes happening in that innermost part of the hurricane. There's so much things going on there. Our computers still aren't down to a level to where they can really resolve everything going on. Another limitation is data over the vast oceans. Satellite helps us, but we don't have measurements of wind, air pressure, temperature in every part of the ocean. That's why hurricane hunters become so valuable, because they can fly in the storm, they can help get those measurements. What a lot of people don't know is we could have a hurricane where there's much disagreement in the computer models. One could be going this way, one could be going that way. What do we do? Well, what NOAA will do is we will send out hurricane hunters and other what we call G4 aircraft that samples the environment several hundred miles around the hurricane. And all that data starts getting put in to the computer models. And a lot of times that spread really starts to narrow because those computer models are getting more and more real data. That's really, I think, that's the ultimate answer is the more real data we can get for our computer models and our computing resources, we're only going to get better in time. But we're never going to be able to pinpoint it. Not in my lifetime anyway. Maybe somebody else's lifetime, but not mine.
Storm surge, where can I find a decent map of Mobile?
Regarding
Storm surge,
so
projected surges.
well, it's storm specific. So during a storm, we produce maps. That storm surge flooding map I was showing you, we will produce that with each storm that's coming up our way. So you get it on our website, or you go to the Hurricane Center website, and they will show the potential storm surge flooding map. So that will show the areas that could potentially see that level of water. It's not a guarantee because remember I talked about that uncertainty. There's going to be those winners and losers, so to speak. Those that get it, those that don't. But we produce them for every storm. Emergency management officials can give you some good ideas based on roughly the category of the storm. Again, it's not just category related, but based on certain things, how far the water can get. Emergency management is a great tool for that because that's how they define their evacuation zones. How far, based on different simulations of hurricanes, what could come in. But it's storm specific. We have one storm that's a category 3 and another storm that's a category 3, but they have different wind fields, can completely change the storm surge equation. So I really, encourage people to focus when the storm is approaching in that storm specific information. But your emergency management officials can help you identify kind of what vulnerability you have based on your elevation to the coast. That's a great place to start. Yes, go ahead.
What kind of training do you have to do what you do? I have a cousin who's getting a PhD in, I think it's climate science. So
Oh, wow.
what are the various academic disciplines that help us project and
Sure.
determine what's going to happen with climate?
Sure. So when it comes to meteorology and the climate, there's kind of a broad range. Myself, for example, I'm a meteorologist. I'm not a climatologist. I'm a meteorologist. Different meteorology is the day-to-day weather, what's going to happen over the next 7 days, being able to provide that specific information as storms are approaching. That's what my focus and our team's focus is at the Weather Service. We have a climate division that's more kind of the long-range picture of temperature and precipitation. So it's more long-ranging projections than what we can do storm-specific in meteorology. So for myself, I have a 4-year degree from the University of South Alabama in meteorology. Took way too many math classes. Scare myself talking about them. Lots of physics, math-based science. But a lot of our meteorologists have master's degrees in meteorology or climatology if they're in the climate side. And we have some PhDs as well, especially when it comes to the modeling aspect, developing our computer models. Many of those people have masters and PhDs because it is a very complex thing. Now, even having said I had a 4-year degree, we've gone through extensive continuous education, through our careers because the science is changing. As we learn more, science changes. And also the tools that we have. So we're always learning, we're always doing training, trying to get better. I really appreciate your time. It's been wonderful speaking with you all. If you ever need us, again, this is our contact information. Don't be shy. We're here for the public. So thank you so much.
Thank you.